Hello, madam. Hello, sir. This is Darnapu Ganesh. Hall ticket number 21955A0302. Mechanical Engineering, third year, fifth semester, Iare College. Now I am going to present my Tech Talk, Tech Talk video on low temperature organic Rankine cycles using natural working fluids. Before going to the introduction, it is important to discuss what is Rankine cycle. Rankine cycle. Rankine cycle is a theoretical cycle. Rankine cycle is a theoretical cycle. It consists of boiler, turbine, condenser, feed pump. Firstly, the water boils at boiler, and the function of boiler is to convert the water from water to steam. So the generated steam is flow through the via nozzle and hits the blades of the turbine. Then automatically turbine starts rotating. Then when the turbine start rotating, the power will be generated. We already know the basic working. Turbine, the basic working of a generator is from mechanical to electrical. So the shaft is do the mechanical work, then electrical work is generated in the generator. So the generator, the power which is generated from the power which is generated from the generator will supply to the through the lines of wires. So after hitting of the steam from the boiler, then it's the steam is sent to the condenser. So the purpose of the function of condenser is it will cool the water. It will cool the vapor from water. Then again the water is sent to the feed pump. The water which were cooled from the condenser sent to the feed pump. So that the water is sent to the again boiler, and the again boiler generate the steam, and the generated steam will hits the blade. Again this cycle process. And remember, the Rankine cycle is a theoretical one. Okay, this is the brief introduction of Rankine cycle. Okay, now we will go. Now we are going to discuss about introduction to the temperature organic Rankine cycle using natural working fluids. So the name itself indicates that here we are using natural working fluid in spite of using hydraulic or steam, any other things. Here the only thing here we are going to replace the working fluids. Okay, now introduction. Due to the depletion of fossil fuels resources and their high environmental loading, load renewable resources are becoming more prominent. In addition to wind, water, and solar energy, which are now widely used as a whispered, and other renewable energy resources are also available due to their heat content. These include geothermal heat, non-fused solar energy, and thermal energy from the combustion of biomass. Here the point, this slide showing telling that due to depletion of fossil fuels, nothing but exhausting daily natural resources are exhausting day by day, because we are using rapidly in order to distribute the power to the requirement, because India is a large second largest population country. So in order to fulfill their requirements of power electricity, we need to generate more power to the requirement. So that is the reason there is a depletion of fossil resources. And also renewable resources are becoming more prominent. However, in these cases, we cannot use conventional technologies for heat recovery because they can produce only a much lower maximum temperature. At this point, organic Rankine cycles come into view because they are capable of phase change at lower temperature, which can make them excellent use of this type of sources. This idea using fluid other than water as a working fluid of Rankine cycle was first as a beginning 19th century, but it was not widely used until the oil crisis of 1997. The idea we already the title itself saying that it is a low temperature organic Rankine cycle. That means it is working under the lower temperature, and also it can able to work under the phase changing of the at the lower temperature. This is the main part, and it is a excellent to use this type of sources. It is and also idea behind work. And also these organic Rankine cycle not only work under the working fluid as Rankine, and not only with water, it is work with oil. It work with oil or any other fuel. The idea is the why it is because the oil crisis is going on. The recognition that fossil fuel could be exhausted in the near further made alternate heat source like geothermal energy come to fore. More and more companies have started to produce geothermal units, and the capacity of these plants have shifted to megawatt size. The most common used working fluid were hydrocarbons, chlorocarbons, and chlorofluorocarbons. During this period, the energy of industries waste heat was also started be utilized for the organic Rankine cycle system were used as well. By using of these geothermal units, we can produce megawatt current. And also the most commonly working fluids of the geothermal are hydrocarbons, chlorobenzene, chlorobenzenes. These three are very more danger to the atmosphere. In order, we have to eliminate this by using of a natural cycles, natural resources. An important part of the research is selection of working fluid. Several papers have been the properties of possible fluids have been studied according to their applicability in organic Rankine cycle system. Various methods have been developed to determine the optimal applicability in overseas systems. Various methods have been developed to determine the optimal material based on the known advantages properties. We are looking for the factors that easy measure of output power of a plant. It has been shown that optimal equipment temperature are not depend on the working fluid, but the working fluid of a Rankine cycle can be selected as a posterior A. Based on this statement, selected most appropriate working fluid, the basis of pressures, temperature, and mass flow of the cycle. They also consider environmental safety implementation. The power plant uses cascade organic Rankine cycle technology to produce electricity. The nominal power of a power plant is 2 megawatt, but the current produced depends largely in the environmental conditions. See, the the characteristic of a working fluid is basically pressures, temperatures, and mass flow. These three are the most important features in order to run the one run the organic Rankine cycle. I repeat, pressures, temperature, mass flow of the cycle. These three are important. And the power plant uses a cascade OC technology to power and the nominal power can be generated is that is 2 megawatts by using these organic Rankine cycles. Most of the thermal well falls into 35 degrees and 50 degrees and considering outflow temperature, which makes the ideal balanced logical agriculture uses. As a heat source of energy applicable, only the thermal water with more than 70% outflow to the can be temperature used. The lower temperature wells are economical for district heating. 90 to 100% temperature can be suitable for producing electricity. We already know the thermal power plant station, which is located at Kottagudam near Khammam, it is, and also Ramagundam. The areas of the temperature is very high, like it reaches mostly like 60 degrees. In Telangana, anywhere in Telangana won't reach that much of temperature. And also it is a finest example that it can reach up to high level. So at that time, at that places, the thermal plants can be suitable. So the points itself indicating that in thermal plants, nearly 35 to 50 degrees and 50 to 70 degrees, it may be varies intervals. So that is the temperature. At best, geothermal sources in the only reach the maximum temperature of 100 to 150, which makes them not suitable heat source of conventional water steam, working fluid Rankine cycle. The reason is that geothermal heat sources do not have enough heat content to evaporate the working fluid sufficiently. Therefore, water is not the best possible working fluid for such heat sources, but replacing it with an organic materials which has lower critical parameters can provide a more feasible cycle. The binary systems are called organic Rankine cycles. Organic Rankine cycles. An organic Rankine cycle can be separated in 4 different: pumping, heat input, expansion, heat removal. Shows the temperature specific entropy diagram of basics ideal organic Rankine cycle between 0.12 and pumping. Fluid and evaporated. According to the endpoint of the heat transfer, saturated vapor and superheated vapor. So superheated vapor cycles are separated. In the case of superheating, the working fluid is evaporated. In the heat exchanger, then the temperature dry vapor is produced, which is expanded in the turbine. So basically, this, if you consider this, it is a pump, it is a boiler, it is a turbine, it is a condenser. You can imagine this is a basic Rankine cycle. So here pump, boiler, turbine, and condenser. So here the point, the different parts of a organic boiler is 1 to 2. From here to is pumping and compression isentropic, and from 2 to 3 fluid evaporated and steam is sent to the turbine. And also at this point the saturated vapor and superheated vapors are separated, and superheated working fluid and this is here the water is expanded. However, in the case of saturated steam process, the heat however, in case of saturated steam process, the heat is stopped at a saturation temperature. So saturated vapor is led into the turbine. So before steam entered into the after boiler, the saturated steam is entered into the turbine. So here the saturated steam is going to enter into the turbine. In the turbine, the working fluid is expanded. We are just now we discovered in turbine the working fluid is expanded. Then the fluid coming out of the turbine, which is dry at steam, and depending the type of working fluid is transformed to the condenser, where the fluid is converted back into the liquid. Then the cycle is again the with pumping, where the fluid is coming back into the liquid in condenser. However, in the case of real process, there are many sources of loss. During the pumping, the working fluid will get warmer. Then it should ideally, so that irreversibility here. So the process is not isentropic, but it is entirely entropy process. Ideally, the heat input should occur at the constant pressure, but as a result, the flow losses in both sides of the heat exchanger, pressure losses appears on the sides. Expansion does not occur with constant entropy. So called irreversibility. Finally, the condensation. Ideally computed in the isobaric pressure. Isobaric nothing but the pressure is at constant. Pressure is constant pressure at constant pressure. The manner but heat inlet the so appears causing pressure losses in condenser and heat exchanger. It is a ideal Rankine cycle, and on the temperature, and this scale indicates the temperature. It is an entropy, specific entropy. As a working fluid of a Rankine cycle, investigated six naturally occurring normally propane, butane, isotopane, and exile. These three are the working fluids: propane, butane, isobutane, N-pentane, isopentane, and the exile. Some of these commonly used material for refrigeration technology and represented that these fuels are particularly suitable for use in organic natural systems. Traditionally, working fluids can be divided up into three groups based on the quality of the expanded vapor at the turbine. Wet turbine, isentropic in case of material, isentropic expansion starting and the working. These few are working fluid. However, since the steam would still reach the condensers, a subsequently superheated state, as a result, high cooling demand would occur. As a solution, repetitive heat exchanger installed in front of condenser, where the exhausted steam cools down the condensing to a saturated vapor state, will preheat the liquid entering The vapor, these addition to reduce cooling demand as a positive effect on the Carnot's efficiency, increase the overall heat removal temperature. Condenser. This is boiler. This is pump. So here expander is going to be installed. Another very important aspect of working fluid selection is how the material behave in a safety related manner. All of the used alkanes are highly flammable and expandable. That propane, butane, pentane, hentane, or hexane, or they are alkenes and which is highly flammable. So we have to look over the flammable fuels because they are high flammable fuels. In the face of the evaporate quickly, the vapor is heavier than the air. So the form explosive mixture with air. Every ignition source need to remove from the. This reason it is important to closed cycle, closed system. The does not generate sparks and the site has appropriate. So that is the reason a Rankine cycle is a closed cycle. In order to eliminate the ignite the spark, flammable fuels to the spark. That is the reason they are closed system. The 6 working fluids are divided into 3 groups. The thermodynamic property, especially critical temperature, saturated curves, material significantly, diffuser, and the punch. These major groups can separate into propane is low, butane and pentane is moderately, and pentane is a high carbon temperature. First one is propane is low, and the butane is butane and N-butane, isobutane are high, and these are high. The pressure used in the internal cycle can be superheated according to the 3 groups. High pressure was required for the propane to operate the system. Medium pressure was sufficient for N-times butane, and so N-10 and butane hexane are recognized as low pressures. For feasibility, condenser pressures were set while the organism was inlet. So this is a thermal water, this is a cooling water, and this is a turbine, and it is a condenser. It is a turbine. It is a turbine. It is a pump. It is a boiler. So feeded water is, the cooled water is came to the pump, and the pump is feed to the boiler. The boiler generate the steam and the send to the turbine, and here expander is there. Expander send to the. This is the basic working of an ideal cycle. That is organic cycle. Conclusion. The thermal is still considered to be a low temperature heat source that can be utilized in power generation by fitting an organic Rankine cycle. During the modeling electric power output, the thermal parameters of the cycle and the efficiency of the system were studied in case of 6 alkane cycles. Although propane, butane, isobutane, hexane are structurally close to each other using different systems due to the different thermodynamic properties like critical point. So why this cycle is closed cycle? Because these alkanes gases are very high flammables, and if we just ignite it, it will touch or ignite more fastly than any fuel. That is the reason it is a closed cycle. So these 6 are used as a natural working fluids in an organic Rankine cycle. Thank you.